Okay, so today we're going to talk about the definition of a derivative. Okay, so if you remember from last class, that when you have some function, and let's say this is your x-axis and this is your y-axis, this is some point x, which makes this some f of x, and this is some point x plus h, which makes this, I should have moved that down a little bit, f of x plus h. I clean that up a little bit. Can everyone see the pencil on here? Okay. I know sometimes with pencils a little bit lighter, so it's maybe hard to see. Let's see if the light helps. I don't like the shadow right here, so I'll leave it like that. Okay, so we know that our secant slope, which is normally y2 minus y1 over x2 minus x1, becomes f of x plus h minus f of x all over x plus h minus x just becomes h. Okay, so there's just our slope of the secant line. Okay, so we noticed that before, when we move our x plus h closer and closer and closer, to x, let's say if we have that same graph, that's our x and that's our y. Let's say this is our x. Let's say instead of up here, we move it down to here. Well, this is our x plus h. Again, this is our f of x. And this is our f of x plus h. Okay, so what if we move it just a little bit closer and we just keep moving it closer and closer and closer? Okay, so if this is our x and y axis, if this is our x, f of x, and let's say we move it even closer, this is our x plus h, and this is our f of x plus h. Okay, so we notice on this one that this is our distance of h. Notice here, this is our distance of h. Here, our h is getting shorter and shorter and shorter with each time we move it. Okay, so let's say we decide to move it almost infinitely closer. To x. So it's so close you can barely even tell the difference. Okay, so if you have that, let's have our x and our y-axis. Okay, so let's say this is our x, and our x plus h is so close. Oh, sorry about that. Okay, it's so close it's barely any space between it. Okay, so if you look where we started, this was our slope between those 2 points. And as we move it closer, notice our slope gets a little bit closer to that point there. Oops, missed that one. To where at some point, that slope just kind of barely skates by that point. That's the only point on the graph that it touches. It doesn't go between any 2 points. And we knew that was our instantaneous rate of change at x. As x plus h approaches x. Okay, so that's what we did last time. Okay, but when you just move it one by one by one by one, you can only go so far. So what you want to do is you want to have your h approach almost 0. So we kind of figured here that we know that it will never hit 0, because if it hits 0, then you have a denominator of 0. It just won't work. But you want to get it as close to 0 as possible. And that's where the limits come in. Okay, so let me leave that up there for a second. Oh, actually, I should have a little bit of room to write that. Okay, so you have the limit as h approaches 0 of f of x plus h minus f of x all over h. And that's your limit definition of a derivative. And move that up some. So what's that? That's going to give us this really, 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 really close approximation. So close that you might as well say it's accurate. You can have it within 1/1,000,000th of a whatever unit of measure you're using, and that's pretty accurate. So, all right. So any questions on this one? All right, I'll leave that up there for a few seconds. All right. Okay, so the limit f of x plus h minus f of x all over h as h approaches 0 is equal to, well, denoted by f prime of x. So this can read one of two ways. F prime of x, or the derivative of f of x. Okay. So if you see the derivative of f of x or f prime of x, really just the same thing. Okay, so you know that we have the average rate of change as we get closer and closer together. That's why that average rate of change, f prime of x, is also, oh, that's a little bit close, called the velocity function. Since it measures your rate of change at a certain point. Okay, so in most cases, you'll see just a regular function okay, so instead of f of t, they just use s of t. And when you get the derivative of that, s prime of t, they usually just substitute that with v of t. And that would be your velocity function. So it's really just the derivative of whatever your position function is. Okay. So any questions on that one? All right.
So the S is just like f of t.
Exactly.
And then f of prime of t turns into, no matter whether you're using s or f, it turns into v of t.
Exactly. So really just whatever you have f of t equals 3t squared plus 7t plus 5. You can just make that s of t and then s prime. You'll see usually as s for a position function. So you'll see that probably more with
for like physics right there. When you're
yeah.
talking about, because if you take the derivative again, you get the acceleration.
Exactly. So you have your position function, your acceleration your velocity function, then your acceleration function when you take the derivative of your velocity function. We're going to go over it all again, so you don't have to remember that just yet. Like I said, this is when we go into second derivatives, we're going to go over this all again. So, okay. Any other questions on this one? All right. Okay, so let me see that one. Okay, so let's say, for example, move that up a little bit. If you wanted to find the correct limit definition for the derivative g of x equals square root of x plus 1. Okay, so really this is just one of those set it up type of problems. You don't have to solve it just yet. We're going to solve it in a little bit. But right now we're just setting it up. Okay. So the first thing you're going to do is find g of x plus h. Okay. And all that is you're going to replace every x with x plus h. Okay, so we know g of x plus h is just going to equal square root of x plus h plus 1. You can put parentheses around that if you want to, but you don't have to since it's all adding. Okay. Now your second step is just, you already know what your g of x is, so you're going to plug that into your formula. Okay, so since g of x is equal to square root of x plus 1, okay, so we're going to plug into our formula. So if g prime of x is equal to the limit of g of x plus h minus g of x all over h as h approaches 0, then that's going to equal the limit as h approaches 0, or g of x plus h. We already know what that is. So square root of x plus h plus 1 minus your g of x, which is square root of x plus 1, all over your h. Okay, so that would be the limit definition you would use. Okay, now as far as solving it, we're going to get into that in a few minutes. But that's where you would go for that one. I think on the homework, a lot of these are multiple choice, so they'll have like 4 or 5 different options, and you have to just pick the right one. All right, so any questions on that one? All right. Just examples of the limit definition. Set up. That was a little bit messy. Now, when we actually start to solve the limits, then it gets a little bit lengthy. Okay, any questions on this one? All right. Okay, so mixed up my papers there. Okay. All right, so let's say, for example, oh, thank you. Okay, what is the correct limit definition for f of x equals x squared? Okay, so this one starts off the same way. First thing you want to do is find f of x plus h. Okay, so we know that f of x plus h is just equal to x plus h squared. Now all you're doing is replacing every x with that x plus h. Okay. Now we know f of x is equal to x squared. And we just plug into our formula. Okay, so we know that f prime of x is equal to the limit of f of x plus h minus f of x all over h as h approaches 0. Straighten that up a little bit. Okay, so we know that's going to equal the limit as h approaches 0 of f of x plus h, which is x plus h squared, minus your f of x, which is x squared, all over h. Okay. All right, now to find the actual limit itself, or the limit definition, or the derivative, we'd have to go further. But for right now, we're just setting up. Now, the next example will have us going all the way and solving for it. Yes?
So how do we understand that f of x plus h equals x plus h squared?
Oh, kind of the same way if f of x is x squared, if you have, let's say, f of a, you're just going to replace a with x with a. So if you had f of 3, you're going to replace that x with 3.
Oh.
So whatever's in there, you're just going to replace your x with whatever values that's in there.
So it's just trying to explain to you that the function is x squared, and then we're going to use that function for x plus h. Which is, okay.
Yeah, that makes sense.
Yep.
All right. Click that out. Okay. Any other questions on this one? All right. Oh, I'll leave that up there for a sec. Okay. Okay, so let's say for the next example, if we're given the function g of x equals negative x squared plus 3x, what is the correct limit definition of g prime of 2? Right? So we start off pretty much the same way. The only thing is you have like one small step afterwards once we're done. Okay, so your first step is you're going to find g of x plus h. Okay. So we know g of x plus h is we're going to replace every x with x plus h. So that's negative x plus h squared plus 3. Oh, is that plus minus? Yep, plus 3 of x plus h. All right. Now your second step, since we already know what g of x is, negative x squared plus 3x, we just plug them both into the formula. Okay, so we know our g prime of x is going to equal the limit of f of x, oh, sorry about that, g of x plus h minus g of x all over h as h approaches 0. Clear that equal sign up. Okay, so we know our g of x plus h is negative x plus h squared plus 3 of x minus your g of x, which is negative, uh-oh, forgot my x plus h, sorry about that. Minus your g of x, which is negative x squared plus 3x, all over h. Okay, so now we can kind of simplify this a little bit. The limit as h approaches 0 of negative x plus h squared plus 3 x plus h plus x squared minus 3x all over h. Actually, they probably could have skipped a step and just went ahead and distributed this now. So it can be 3x plus 3h. That would help some space. Okay. So if you notice, the 3x's cancel out. Minus 3x plus 3x. Okay. So we go to the limit negative x plus h squared plus 3h, sorry about that, plus x squared all over h as h approaches 0. Okay. So we know this is our g prime of x. Okay. Now with this one, you add a third step because now we know what x is equal to. Since x is equal to 2, we just plug 2 into there and replace every x with 2. That x is equal to 2. So we know our g prime of 2 is going to equal the limit as h approaches 0 of negative 2 plus h squared plus 3h plus 2 squared all over h. And we just simplify it from there. The limit as h approaches 0 of negative 2 plus h squared plus 3h plus 4 all over h. Okay. So when they ask for the limit definition, this is what they're looking for. When they ask for it at a specific point, they just mean you're going to replace the x with that value. Okay. So any questions on that one? All right. Oh, yes.
Could you, say this, you see that 2 plus h, could you just go ahead and times that by itself?
Not in this step. In the next one we will. And that's when you have to go to all the extra steps. With this one, it's just strictly a setup. All right. Okay. Any other questions on this one? All right. We're at 28 minutes, so it's going to be cutting off soon.